Welcome to my channel, The Proper Guidance. Here we are today to discuss about chapter number 11, Data Communication of Class 12 Computer Science. Okay, in this chapter we will learn about concept of communications, components of data communication, measuring capacity of communication media, types of data communication, switching techniques, transmission media, mobile telecommunication technology and protocol. These are the topics which will be discussed in this chapter. First, concept of communication. The term data communication comprises of two words, data and communication. Data can be any text, image, audio, video and multimedia files. Communication is an act of sending or receiving data. Thus, data communication refers to the exchange of data between two or more network or connected devices. These devices must be capable of sending and receiving data over a communication medium. Examples of such devices include personal computers, mobile phones, laptops, etc. As we can see in figure 11.1, four different types of devices, computer, printer, server and switch are connected to form a network. These devices are connected through a media to the network which carry information from one end to other end. Here is the picture, a simple network of computing devices. There is a switch, central server, sharing printer is also there and 2-3 computers are there, and you may call this node also. Okay. Now, components of data communication. What do you mean by components of data communication? Whenever we talk about communication between two computing devices using a network, 5 most important aspects come to our mind. These are sender, receiver, communication medium, the message to be communicated, and certain rules called protocols to be followed during communication. So, the communication media is also called transmission media. The same thing, transmission media or communication media. Now, these components are here. First one is sender, and who sends the message? See, is the sender, and who receives the message is known as receiver. Within sender and receiver, there will be the transmission media as well as the message itself. Okay. Now, sender. A sender is a computer or any such device which is capable of sending data over a network. It can be a computer, mobile phone, smartwatch, walkie-talkie, video recording device, etc. Same thing, receiver. A receiver is a computer or any such device which is capable of receiving data from the network. It can be any of computer, printer, laptop, mobile phone, television, etc. In computer communication, the sender and receiver are known as nodes. They are also known as nodes in a network. Message. What is message? It is the data or information that needs to be exchanged between the sender and the receiver. Messages can be in the form of text, number, image, audio, video and multimedia, etc. Communication media. Communication media means it is the path. It is the path through which the message travels between source and destination. It is also called medium or link, which is either wired or wireless. For example, a television cable, telephone cable, Ethernet cable, satellite link, microwaves, etc. We will study about various communication media in this section. And then comes the protocols. It is a set of rules that need to be followed by the communicating parties in order to have successful and reliable data communication. You have already come across protocols such as Ethernet and HTTP. We have learned it in the previous chapter. So, these 5 things are very important terms for communication, data communication. Now, measuring capacity of communication media. Measuring capacity of communication media means in data communication, the transmission medium is also known as channel. The capacity of a channel is the maximum amount of signals of traffic that a channel can carry. It is measured in terms of bandwidth and data transfer rate as described below. Now, what do you mean by bandwidth? This is also a very common term. Bandwidth of a channel is the range of frequencies available for transmission of data through that channel. Higher the bandwidth, higher the data transfer rate. Okay. Normally, bandwidth is the difference of maximum and minimum frequency contained in the composite signals. Bandwidth is measured in hertz. 1 kilohertz equals to 1000 hertz, and this thing. So, data transfer rate. What do you mean by data transfer rate? Data travels in the form of signals over a channel. One signal carries one or more bits over the channel. Data transfer rate is the number of bits transmitted between source and destination in 1 second. It is also known as bit rate. It is measured in terms of bits per second. The higher units for data transfer rates are 1 kbps to the power 10 mbps, 1 mbps, this one. You please go through. After that, required data rate we can calculate like this. This is an example. A user wants to upload a text document at the rate of 10 pages per 20 seconds. What will be the required data rate of the channel? Assume that one page contains 1600 characters and each character is of 8 bits. Each character is of 8 bits means 1600 into 8, and there are 10 pages. So 10 into 1600 into 8. Total data to be transmitted. And in which second? 20 seconds. So divide by 20, you can get the required data rate. Required data rate, and that is what? Required data rate, that is 6400. 6400 Mbps. Okay, that is 6.25 kbps. Now, types of data communication. Data communication happens in the form of signals between two or more computing devices or nodes. The transfer of data happens over a point-to-point or multi-point communication channel. Data communication between different devices are broadly categorized into 3 types. That is simplex communication, half-duplex communication, and full-duplex communication. The first one is simplex communication. What is simplex communication? It is a one-way or unidirectional communication between two devices in which one device is sender and the other one is receiver. Okay, it is one way. Devices use the entire capacity of the link to transmit the data. It is like a one-way street where vehicles can move in one direction only. For example, data entered through a keyboard or audio sent to a speaker are the one-way communications. Simplex. You can see it, one direction, only one direction. With the advent of IoT controlling home appliances is another example of simplex communication. Then, half-duplex communication. Half-duplex, it is a two-way or bidirectional communication between two devices in which both the devices can send and receive data or control signals in both directions, but not at the same time. While one device is sending data, the other one will receive and vice versa. It is like sharing a one-way narrow bridge among vehicles moving in both directions. Vehicles cannot pass the bridge simultaneously. So basically it is a simplex channel where the direction of transmission can be switched. Application of such type of communication can be found in walkie-talkie, where one can press the push to talk button and talk. This enables the transmitter and turns off the receiver in that device and others can only listen. Okay. And then comes full-duplex communication. It is a two-way or bidirectional communication in which both devices can send and receive simultaneously. It is like a two-way road where vehicles can go through both. So this can be done either by using two physical separate simplex lines, one are sending and other is receiving, or the capacity of the single channel is shared between the signals traveling in different directions. Okay, so these are the techniques we have learned. Now, switching techniques. What do we mean by switching techniques? In a network having multiple devices, we are interested to know how to connect the sender and receiver so that one-to-one communication is possible. One solution is to make a dedicated connection between each pair of devices, mesh topology, or between a central device and every other device a star topology. However, we know that such methods are costly in case of large network. An alternative to this is switching, whereby data is routed through various nodes in a network. This switching process forms a temporary route for the data to be transmitted. Two commonly used switching techniques are circuit switching and the one other is packet switching. Now, circuit switching means, in circuit switching, before communication starts, a dedicated path is identified between the sender and the receiver. This path is connected sequence of links between network nodes. All packets follow the same path established during the connection. In earlier days, when we placed a telephone call, the switching equipment within the telephone system finds out a physical path or channel all the way from our telephone at home to the receiver's telephone. This is an example of circuit switching. And packet switching, in packet switching, each information or message to be transmitted between sender and receiver is broken down into smaller pieces called packets. These packets are then transmitted independently through the network. Different packets of the same message may take different routes depending on availability. Each packet has two parts: a header containing the address of the destination and other information, and the main message part. When all the packets reach the destination, there is assembled and the complete message is received by the receiver. Unlike circuit switching, a channel is occupied in packet switching only during the transmission of the packet. On completion of the transmission, the channel is available for transfer of packets from other communicating parties. Now, transmission media. A transmission medium can be anything that can carry signals or data between the source transmitter and the destination, that is receiver. For example, as we switch on a ceiling fan or a light bulb, the electric wire is the medium that carries electric current from which switch to the fan or bulb. 2 minutes talking and showing figure this and fan. How are you, Jason? As well. In data communication, transmission media are the links that carry messages between two or more communicating devices, and they can be of two types. One is guided, another one is unguided. In guided transmission, there is a physical link made of fiber cable through which data in terms of signals are propagated between the nodes. These are usually metallic cable, fiber optic cable, etc. Okay, they are known as wired media. In unguided one, data travels in air in terms of electromagnetic waves using an antenna. They are also known as wireless media. Communication media, this is a chart. Look, wired media and wireless media. Wired media, twisted pair cable, coaxial cable, fiber optic cable. This is all about wired media. Wireless media, radio waves, microwaves and infrared waves are there. Now, there are so many points are there. I am just highlighting the main portion. You people please go through the entire thing. We are now talking about wired transmission media. Any physical link that can carry data in the form of signals belongs to the category of wired transmission media. These three commonly used guided or wired media for data transmission are twisted pair, coaxial cable and the fiber optic cable. Twisted pair and coaxial cable carry the electric signals, whereas the optical fiber cable carries the light signals. Twisted pair cable. Twisted pair consists of two copper wires twisted like a DNA helical structure. Both the copper wires are insulated with plastic covers. Usually a number of such pairs are combined together and covered with a protective outer wrapping as shown in this figure. Each of the twisted pairs act as a single communication link. The use of twisted configuration minimizes the electric effect of electrical interference and all those things. And then comes coaxial cable, UTP and STP coaxial cable. Coaxial cable is another type of data transmission medium. It is better shielded and has more bandwidth than a twisted pair as shown in figure. You people please go through, and the diagrams are also very important. Okay, you people please go through all this topic about optical fiber. This is written in very plain English. You people please go through as short note. And after that, wireless transmission media. In wireless transmission media, electromagnetic spectrum range, there are different types of range in wireless communication technology. Information in wireless communication technology travels in the form of electromagnetic signals through air. Electromagnetic spectrum of frequency ranging from 3 kHz to 900 THz is available for wireless communication. Okay, wireless technologies allow communication between two or more devices in short to long distance without requiring any physical media. There are many types of wireless communication technologies such as Bluetooth, Wi-Fi, WiMAX, etc. The electromagnetic spectrum range from this to that can be divided into 4 categories. First one is radio waves, microwaves, infrared waves, and visible or light waves according to their frequency of ranges. So here is the picture of electromagnetic wave spectrum. First one is radio wave. Range is 3 kHz to 1 GHz. From 1 GHz to 300 GHz, this is known as microwaves, and from 300 GHz to 400 THz, it is known as infrared, as well as from 400 THz to 900 THz, it is known as light waves. After that, classification, transmission waves and their properties are here. Radio waves. First one is radio waves. Waves of frequency we have learned. First one. Then omnidirectional. These waves can move in all directional. Omnidirectional means can move it can move in all direction. Next, radio waves frequency can travel long distance, susceptible to interference, and radio waves frequency penetrate walls also, and these waves are used in AM, FM radio, television, cordless phones. Okay. Next, microwaves. What is microwaves? Electromagnetic waves of frequency range from this one. Unidirectional, can move in only one direction. This is the basic difference between radio waves and microwaves, because radio waves are omnidirectional, where microwaves is unidirectional, cannot penetrate solid object such as walls, hills or mountains. Needs line of sight propagation, that is both communicating antenna must be in the direction of each other. Used in point-to-point communication or unicast communication such as radar and satellite. Provide very large information carrying capacity. Okay. Next one, infrared waves. Electromagnetic waves of frequency range. This thing, very high frequency waves, cannot penetrate solid objects such as walls. Used for short distance point-to-point communication such as mobile to mobile, mobile to printer, remote, and all those things. Okay. Now, wireless technology. What is the wireless technology? People also know about Bluetooth, short range wireless technology, connecting mobile phone, mouse, headphone, all those things, Bluetooth technology. You people please go through. And wireless LAN is also there, wireless LAN, Wi-Fi. In our today's life, we are all acquainted with Wi-Fi technology, right? So, what is the theory part? You people please go through. If there is any problem, please feel free to ask me. After that, here is mobile telecommunication technology. In mobile telecommunication technology today, the mobile phone network in the world, the architecture of the mobile network, this chapter, I am just highlighting the main portion. They are identified as 1G, 2G, 3G, 4G and latest 5G, right? Let us briefly discuss the mobile telecommunication generations. The first generation, 1G mobile network system, came around 1982. It was used to transmit only voice calls. The analog signals were used to carry voices between the caller and the receiver. This is about 1G. Second generation 2G mobile network system came around in 1991. Instead of analog signals, voice calls were transmitted in digital form, thus providing improved call quality. This increased capacity allowed more people to talk simultaneously and led to improved security as the signals could be encrypted. It also enabled an additional service to send SMS and MMS, multimedia messages. Okay. Then the next one is the third generation 3G mobile network technology was developed during late 90s, but it was introduced commercially around 2001. It offered both digital voice and data services. 3G provided internet access via the same radio towers that provide voice service to the mobile phone. It facilitated greater voice and data capacity also, and therefore more simultaneous calls could happen in the same frequency range and also significantly faster data transfer speed. Demand for faster data is always increasing, and thus 4G mobile networks were developed, and now in today's world 5G network have also come into being. Now 4G is much faster than 3G, and this has revolutionized the field of telecommunication by bringing the wireless experience to a new level of altogether. 4G systems support interactive multimedia, voice, video, wireless internet and other broadband services. Technologically, 4G is very different compared to 3G. The 5th generation or 5G is currently under development. It is expected to be a milestone development. Already this is in our today's world. Machine to machine is direct communication between devices, wired and wireless. 5G. Okay, 5G is allow data transfer in Gbps, which is much faster than 4G. It is expected to be able to support all the devices of the future connected vehicles. Okay, so these are all about generations of mobile phone. Now protocol. Protocol means some rules and regulations. In communication, protocol is a set of standard rules that the communicating parties, the sender, the receiver and all other intermediate devices need to follow. We know that the sender and receiver can be parts of different networks placed at different geographical locations. Besides, the data transfer rates in different networks can vary, requiring data to be sent in different formats. Need for protocols. We need protocols for different reasons such as flow control, access control, addressing, etc. Flow control is required when the sender and receiver have different speeds of sending and receiving the data. Okay, access control, flow control. Flow control is required when the sender and receiver have different speed of sending and receiving data. Now, data at the speed of this one. In this case, computer, we must be able to inform computer about the speed mismatch so that the computer A can adjust its data transmission. This is about flow control. Means suppose some students are in a classroom, right? Now all the students are not equally intelligent. Someone can understand easily. Some students may take some time. Okay, now the lecturer who is giving the lecture, that speed is mismatched with some student's speech, student's capability. Then the student the student has to inform the teacher that teacher, I cannot understand, please repeat. Just like that. There is some flow control. Flow control is required when the sender and receiver have different speeds of sending and receiving the data. And the second option is access control is required to decide which nodes a communication channel will access. The link shared among them at particular instant of time. Otherwise, the transmitted data packets will collide if computers are sending data simultaneously through the same link, resulting in the loss or corruption of data. So, protocols also define how computers identify one another on a network, the form to which the data should be converted for transit, how to decide whether the data received is for that node to be forwarded to another node, ensuring that all the data have reached the destination without any loss, how to rearrange the packets and process them at the destination. If all the rules or protocols of communication network are defined at one place, it becomes complex. To ensure that communicating parties follow the guidelines, in this section we will briefly talk about some of the protocols required in communication. HyperText Transfer Protocol, HTTP. HTTP stands for Hypertext Transfer Protocol. It is the primary protocol used to access the World Wide Web. So HTTP is a request to response, also called client server protocol, that runs over TCP. And the common use of HTTP is between a web browser and a web server. I am just highlighting the points. These are very important one. You people please go through the entire text material. The video will be lengthy, that's why I am highlighting this portion. HTTP facilitates access of hypertext from the World Wide Web by defining how information are formatted and transmitted, right? And next comes File Transfer Protocol. File Transfer Protocol, what it actually is, the protocol used for transferring files from one machine to another. Like HTTP, FTP also works on a client server model. When a user requests for a file transferred with another system, FTP sets up a connection between the two nodes accessing the file. Optionally, the user can authenticate using user ID and password. The user then specifies the file name and location of the desired file. After that, another connection sets up and the file transfer happens directly between the two machines. However, some servers provide FTP logins without authentication for accessing files. File transfer between two systems seems simple and straightforward because FTP takes care of issues between two communicating devices. Okay. Now, P means point-to-point protocol. This is another one, dedicated and direct connection between two communicating devices. You people please go through the entire thing. Next, simple mail transfer protocol is here. This is used for written on the message header like an envelope on a letter, and it's not concerned with the content of email message. Each email header contains email addresses of recipients. You people all know this. The email containing header and body are entered into a queue of outgoing mails. Then the SMTP sender program takes mails from the outgoing queue and transmits them to the destinations. When the SMTP sender successfully delivers a particular mail to one or more destinations, it removes the corresponding receiver's email address from the destination list. When that mail is delivered to all the recipients, just like it will be worked. Next, TCP or Transmission Control Protocol, or this is also known as Internet Protocol. It is a set of standardized rules that uses a client-server model of communication in which a user or machine requests a service by a server in the network. The IP protocol ensures that each computer or node connected to the internet is assigned an IP address which is used to identify each node independently. It can be considered to be the adhesive that holds the whole internet together. TCP ensures that the message or data is broken into smaller chunks called IP packets. Each of these packets are routed through the internet along a path or from one router to the next until it reaches the specified destination. TCP guarantees the delivery of packets on the designated IP address. It is also responsible for ordering the packets so that they are delivered in sequence. There are many redundant connections paths in the internet with backbones and ISP connecting to each other in multiple locations. So there are many possible paths between two hosts. Hence, two packets of the same message can take two different routes depending on the congestion and other factors in different possible routes. When all the packets finally reach the destination machine, they are reassembled into the original message at the receiver's end. This is all the techniques followed by these protocols. Okay, so here we have completed chapter number 11. This is all about data communication. Next day we will learn something new in the next chapter. Till then, take care and thank you for watching.